morning, Nana, everyone.
Good morning.
Good morning, sir.
Finally, chemistry class is over. Right. So, shall I start the class?
Yes, sir.
Myself. Okay, coming to here. Oh, who is this? Right. Yesterday, I think we were in the middle of some concept. Not middle, I think started one
Sir,
concept.
కొత్త థియరీ సార్
Acha, acha.
at low frequency. Sorry, high at low wavelength.
My voice is low, Nana.
లేదు సార్ వినిపిస్తుంది.
అంటే రోజులాగా లేదా?
నిన్న ఇంకా లాస్ట్ ఒక కొద్ది రోజుల్లో చాలా మంచిగా వచ్చింది సార్. ఈరోజు మళ్ళీ కొంచెం తగ్గింది కానీ వినిపిస్తుంది.
వేరే డివైస్ కనెక్ట్ అవుతాయి. Now, are you able to hear clearly, Nana?
Yes, sir.
ఎస్ సార్.
Now, is it loud and clear?
ఎస్ సార్.
Yes, sir.
Okay, right, Nana.
Yes, sir. Clear, sir.
Okay, then. Come to here. What the concept yesterday? That is, I think, when the incident rays are not in the range of ultraviolet to IR, UV to IR. If the wavelength is less than the wavelength of like X-rays, that is less than 100 angstroms, then what happens? Okay. So here Compton found that is actually the effect for dot photoelectric effect that is called as Compton effect. What the Compton found and how he explained this concept, not based on the complete absorption. Complete absorption is photoelectric effect. In this case, he observed that in any material, why? Because there is no concept of complete absorption. We require some free electrons, okay, whether they are less or more. That's why he did not mention the target what you are taking here, not necessarily the conductor. Okay, any material you can take there, but some free electrons are required there in that material. And here, suppose one light ray, like or electromagnetic wave or some X-ray, this should be according to Compton effect, either X-ray or gamma ray. Since gamma rays have more energy compared to X-rays, he conducted the experiment with gamma rays now. Okay, that's why here, if you send the gamma rays towards surface, this is called as target. Okay, and the X-ray hit the target, then what he said, this X-ray or gamma ray according to quantum theory, not wave theory. Means one more support we are getting for quantum theory. Okay, like wave theory means few properties of light supported the wave theory, and here few other properties of light supported the particle theory. One, black body radiation. Number two, in this class, in this chapter only, we found photoelectric effect. So till now we came to know that two properties of light support the quantum theory. And now we are finding out the third property of light. What we are saying, that Compton effect, this one also supports the particle theory, Nana, not the wave theory. That's why according to the quantum theory, means we are getting more support to the quantum theory. What he said, the incident gamma ray or X-ray.
Sir, quantum theory.
Pardon, I did not listen anything.
Sir,
Mr. Aryan?
quantum theory means particle. I'm telling sir,
Quantum theory is particle.
Okay, sir.
Yes, quantum theory. Once again, you repeat, Aryan, what you are saying.
No, sir, I was asking, it is same as particle theory or different? I was asking that.
Same as particle theory means quantum theory. According to quantum theory, we assumed the photon as an energetic particle. No?
Yes, sir.
So it is particle nature only.
Yes, sir. Okay,
right.
sir. Okay.
So incident gamma ray or X-ray is considered as a particle, like energetic particle. Okay, as a particle. And here what he said, that particle is going to hit another particle. That another particle is a free electron inside the target. Okay, if the energetic particle hits a free electron in the target, okay, target is like some material. He actually did the experiment with the carbon. We don't know why he selected the carbon, just he took one material. Means I think his intention is to show that no need to take a conductor. Okay, that's why he took the carbon. So a free electron in the target, then the collision between them is considered as elastic collision. Means he is not saying that energy is completely absorbed by the free electron. He is not saying using the absorption of energy. He is trying to say by using the collision theory. Consider elastic collision. Since why you are considering that as elastic collision, sir? This is energy, another is tiny, very tiny particle. Very tiny particle, even though there is mass particle, very less chances of losing the energy in between the two, like converting that some part of energy into sound energy or light energy or some other form. That's why here it is considered as elastic collision. Means obeys law of conservation of linear momentum and law of conservation of energy. So understood this concept, Nana?
Understood, sir.
So he is going into the collision concept, not the absorption concept. Okay, and that too he considered that as this concept as two-dimensional elastic collision. Two-dimensional elastic collision means like Karam's scale. Suppose this is one free electron here, what he assumed inside the target. After hitting this energetic particle with the mass particle at rest, okay, then immediately after the collision, he assumed that the electron will recoil in one direction, means scatter, and the energetic particle travels in some other direction, like a two-dimensional collision. This is like a striker, this is like a coin. After the collision, in Karam's game, coin is at rest. So striker hits the coin, they travel in two different directions, like two-dimensional elastic collision. That's what we assume. And it is the initial direction. So take the initial direction like this here. Initial direction of incidence. Why? Because in that direction only X-ray is assumed to hit the electron. So this is the incidence direction. Okay, this is direction of recoil of electron. And this is the direction of scattered X-ray or gamma ray. Okay, so here we are going into the concept. Okay, Nana Bhargav, no problem. Okay. All right. Then coming to here, suppose if I consider that as two-dimensional elastic collision, then I have to go and recollect the things what we used in our first year, and some extra concepts will be migrated from chemistry. Okay, what are the concepts you are going to use here, sir? Number one, here, first of all, for energetic particle, what will be the linear momentum? Okay, do you know that one, the linear momentum of energetic particle, Nana? Don't know. Okay. Yes. Okay, no problem. Usually what they say here, energy of a photon is equals to, we write E equals to h nu. That one, can I write it as hc by lambda? Okay. And if that energy in this concept, you are considering it as a collision, means energy is also considered as a mass particle, and those two are hitting in like in the Karam scale. If energy is assumed to be a mass particle, then its energy, Einstein gave that it is mc square. Is it correct, Nana? Einstein's equation.
Yes, sir.
Will you accept this one?
సార్ కానీ అక్కడ
Yes,
ఏమంటే
sir.
మాస్ కాదు సార్, దేని మాస్ సార్?
నీకు అసలు మాస్ తో సంబంధం లేదు. నెక్స్ట్ స్టెప్ యూ అబ్జర్వ్ హియర్. 1c get cancelled. That implies mc is equals to, I am getting h by lambda. Mass into the speed gives actually linear momentum. Am I right?
Yes.
That implies you are saying here the linear momentum of energetic particle, here quantum theory, energetic particle according to quantum theory is equals to h by lambda. This is the linear momentum, Nana. Okay, of course, same thing here de Broglie proposed. అంతే కదా నాన్న, ఎవ్రీథింగ్ వైస్ వర్సా కదా, ఫిజిక్స్ ఎప్పుడు వైస్ వర్సా. అంటే here according to quantum theory energy is considered as a mass అన్నప్పుడు mass why don't you consider as a wave? ఆయన ఒక లాజిక్ పట్టాడు. ఎనర్జీని నువ్వు మాస్ గా కన్సిడర్ చేస్తూ మాస్ నువ్వు ఎనర్జీగా ఎందుకు కన్సిడర్ చేయవు? అప్పుడు దాని వేవ్ లెంగ్త్ ఎంత అన్నది నీ కెమిస్ట్రీ డి బ్రోగ్లీస్ వేవ్ లెంగ్త్. I think you know that in your chemistry. De Broglie's wavelength is there, Nana?
తెలుసు సార్, తెలుసు, ఉంది సార్,
ఉంది కదా, కెమిస్ట్రీ ఫస్ట్ ఇయర్ లోనే ఉంది కదా అది.
ఉంది సార్, అవును.
Okay, so nothing to explain there about de Broglie's wavelength. Okay, that was proposed by de Broglie and assumption. Later, of course, proved by some other scientists. Okay, leave it. Now I am coming back to my concept. This one is the linear momentum of energetic particle, which is exactly identical to the de Broglie's concept. Okay, so it is the linear momentum that is E here. The linear momentum is, and the linear moment of mass particle, no need to explain. Okay, so here according to, we are going to the derivation first part. First theoretical part you understood, Nana, and any doubt here in the theory?
No, sir.
No, means
Sir?
he is not taking the absorption.
సార్ ఇక్కడ ఫోటాన్ ని
Yes.
మాస్ పార్టికల్ గా అజ్యూమ్ చేశారు కదా సార్. ఫస్ట్ లో న్యూటన్ అదే అజంప్షన్ చేసినప్పుడు రాంగ్ అన్నారు కదా సార్.
అది మాస్ పార్టికల్ అజ్యూమ్ చేయాల, ఆయన దాని మాస్ అన్నాడు, దిస్ ఈజ్ ఎ మాస్ పార్టికల్ అన్నారు. ఇక్కడేమో అదంటలేదుగా. ఇఫ్ ఇట్ వర్ ద మాస్ పార్టికల్ వాట్ విల్ బి ద ఈక్వివలెంట్ లీనియర్ మొమెంటం కదా వీళ్ళు చెప్పింది.
ఓకే ఓకే సార్,
అర్థమైందా?
అర్థమైంది సార్.
అది అందుకే నువ్వు మాస్ అడిగినా నేను చెప్పలేదు. వై? బికాజ్ ఐ డోంట్ వాంట్ మాస్. నాకు మాస్ కాదు కావాల్సింది లీనియర్ మొమెంటం. రైట్. ఎనీ అదర్ డౌట్స్ హియర్, నాన్న?
No, sir.
No, sir.
నో, షూర్.
Sir, one doubt.
ఓకే, అంటే బేసిక్ డిస్టింగ్విషన్ యూ అండర్స్టూడ్ బిట్వీన్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ అండ్ కాంపౌండ్ ఎఫెక్ట్.
Yes,
Yes,
one
sir.
small doubt.
That is not a collision, but it is a collision. Their total energy is captured by electron, but here energy is not captured by electron. Okay, just by considering the energy as a particle, transfer of linear momentum and energy will be there from one to the other. Okay, this is the basic difference between photoelectric effect and Compton effect, both explained by using quantum theory only.
Sir,
Okay, both. Yes, yes.
sir, yesterday or day before you said that, no, sir, means in wave theory we will have different energy of particle, and in particle theory it is h nu. No, sir.
Different, not different energy. Energy formula is different. What I told.
Yeah, formula. That's what I'm saying. Formula it is here. It is h nu, and there it is something else. No, sir.
Wave that you will get in electromagnetic waves and wave optics.
Yes, sir. In this Compton effect also, then we can apply that particle theory formula. H nu formula we can use.
Here I
Means
am
or
taking
in
not
this-
wave theory. Na. Here I am taking quantum theory. Na.
Yes, sir.
Quantum theory means I require just E is equal to h nu formula only. I don't want that energy what you write in according to wave theory. I don't want it.
Okay. Okay. Okay, sir. Means here also we are taking a small particle, only, mass particle.
Yeah. Here clearly I mentioned. Na.
Yes, sir. Okay.
It is based on quantum theory, and that too here it is considered as elastic collision. Why it is considered as elastic collision? I explain us why. Because it is the collision between two tiny particles.
Yes, sir. Some sound energy.
Very
or-
tiny. Almost tiny.
Okay.
Electron mass 9 into 10 to the power minus 31 kg.
Okay,
Tiny
sir.
particle. So loss of energy is also negligible here.
Okay. Okay, sir.
Right. So coming to here, the linear momentum I said, and I am going to the explanation here in the derivation part. What I write, First, by taking the coordinate system here, taking it as x-axis and taking this one as y-axis. Here, this is my coordinate system. And first I am going to, according to LCLM, law of conservation of linear momentum, I am writing here. Linear momentum is a vector, and you know that in your first year we have to write in both the directions, x-axis and y-axis. Along x-axis, first I am writing the linear momentum of energetic particle is h by lambda. So h by lambda plus, before the collision electron is at rest, so 0 is equals to no Mr. Sachin, స్పీడ్ మనకు ఆల్రెడీ తెలుసు, సో అది అడగరు నేను. ఓకే, రైట్. సో h by lambda, right. H by lambda plus is 0. This is linear momentum of electron. After the collision, both are traveling in two different directions, means we have to write their linear momentum in the two directions. Suppose incident wavelength is lambda, scattered wavelength is lambda dash. Okay, surely I can say E dash is less than E. Will you accept?
Yes, sir.
Why? Because some part of energy should be given to the electron, otherwise electron won't move. Why? Because we are considering this is at rest.
Yes, sir. Sir, ante lambda dash is greater than lambda.
That's what I'm saying. That implies lambda dash is greater than lambda. This is what I'm going to say. Okay, so this one you just keep in mind, Nana. So the scattered wavelength is always greater than the wavelength of incident wavelength, unless energy is not given to the electron, unless it is what I am saying, lambda dash is not equal to lambda, Nana.
Okay, sir.
Okay, lambda, unless here the energy is not given to the electron. Suppose no energy is given to the electron and it is not hitting any free electron inside, that case you can assume lambda dash is equals to lambda.
Okay, sir.
Now is it clear?
Clear, sir.
Yes, sir.
Why? Because we can't say straight away. క్యారమ్లో స్ట్రైకర్తో కొట్టినప్పుడు కాయిన్కి తగలాలని రూల్ ఏం లేదుగా. ఒక్కోసారి మిస్ అయ్యి ఏ కాయిన్కి తగలకుండా వెళ్ళిపోతుంది స్ట్రైకర్. ఓకే, అలా ఏ ఎలక్ట్రాన్కి తగలలేదంటే హియర్ ఎనర్జీ ఈజ్ నాట్ లాస్ట్ అండ్ యూ విల్ ఫైండ్ ద సేమ్ వేవ్ లెంగ్త్ ఆన్ ద అదర్ సైడ్ వితౌట్ ఎనీ స్కాటరింగ్. స్ట్రైట్గా ఇలా వచ్చేస్తుంది. అదొక ఎక్సెప్షనల్ కేస్. In that case only we can say lambda is equals to lambda dash. In all other cases, lambda dash is greater than lambda. Okay, I think you understood. Here no need to explain further about it. And this is considered as the electron and its velocity, you take it as v naught after the collision. And here the recoil angle, you take it as theta. And the scattering angle, you take it as phi. Okay, now I think you are not first year student. You can say by resolving the two linear momenta, you can say along x-axis. Since it is a mass particle, the linear momentum is m into v. Mv resolved into one component, that becomes mv cos theta. Right. And here its linear momentum is h by, yes, its component along x-axis is h by lambda dash cos phi. Okay, this is equation 1. See here how many unknowns are there. V, recoil velocity, I don't know. Theta, recoil angle, I don't know. Phi, scattering angle, I don't know. Lambda dash, scattered wavelength, I don't know. Lambda, incident wavelength, usually they give. So
ఇంకో రెండు
completing that
ఈక్వేషన్
left hand,
రాసుకోవచ్చు.
అదే వస్తున్నాం 1 2 3 4 అన్నోన్స్ ఉన్నాయి నాన్నకి ఇక్కడ
Yes, sir.
ఐడెంటిఫైడ్
Yes,
right.
sir.
Second equation you can say along y axis. Mr. Nihant, what you are saying?
Yes, sir.
Along y axis you can say that is along y axis can I write 0
Zero.
plus 0 before the collision?
Yes, sir.
Why? Because it is moving perfect. I assume to move with to move along x axis. So there is no linear momentum along y axis. 0 plus 0 equals to what to write, Nana?
MV
Sin
sin theta.
theta plus lambda dash
Sin theta.
hy plus hy lambda dash sin phi.
Plus can I write minus h by lambda dash cos phi sin
Yes,
phi?
sir. Yes, sir.
Why? Because both are in opposite direction, Nana.
Yes,
Actually,
sir. Yes, sir.
according to this assumed coordinate system, I have to take
Minus
this one
M1.
as plus and that was as minus. Why? Because if after resolving mv sin phi, sin theta will come down. That is according to our assumption coordinate system. We have to take the linear momentum as negative. So whatever, either this one or the second one is negative altogether. After taking to the other hand, you will get here mv sin theta is equals to what you are getting h by lambda dash into sin phi. Is it correct, Nana? The second equation?
Correct, sir.
Right. Coming to here, I'm just highlighting the two equations here. This is the first equation, and this is the second equation. Still, we require two more equations. Why? Because totally 4 unknowns are there. Since it is considered as elastic collision, what will be the other
Kinetic energy
conservation law, Dana?
Law of conservation
Very
of
good. This
kinetic
is,
energy.
yeah. Yes, this is law of conservation of linear momentum. Later, we are going to law of conservation of according to, I write here, law of conservation of kinetic energy. Okay. What can you write here? Kinetic energy is a scalar, Nana. So no need to consider any directions. Straight away, you can say what is the energy of this photon.
hc by
Incident
lambda.
photon is hc by
Hc
lambda.
by lambda.
Yeah, exactly. hc by lambda. This is the incident energy, and electron is assumed to be at rest, so its kinetic energy is 0. And after the collision, we assumed it travels with a speed of v. So kinetic energy of electron mass
mv
particle
square.
is mv square, half mv square, plus energetic particle is hc by lambda dash of scattered X-ray here or gamma ray. So any mistake is there in my equation, Nana?
No, sir.
No, I think this is correct. So take it as third equation. But here problem is after the collision, here the electrons, even though by taking some part of energy from the gamma ray, it tries to travel almost with the speed comparable to the speed of light. Means like if you see practically here, the velocity of this electron is like c by 10 or c by 20. At that speed, it tries to travel. Like some 3 into 10 power 7 or 1 into 10 power 7, like with that speed the electron tries to travel. This is comparable to the speed of light, Nana. That is not going with 300 meter per second or 4000 meter per second. It is going with a speed of almost 4 into 10 power 7 meter per second. So you understood what I'm saying?
Yes, sir. Approximate to v. C.
Approximate to c, speed of light.
Yes, sir. Yes, sir. Okay, sir.
Approximate to speed of light. Again, same Einstein, what he said according to the relativistic theory, the mass of any mass particle will not be the rest mass of that particle. Means what I am saying, suppose the mass of electron, if I ask, what do you say? 9 into 10 to the power of minus. You are saying in AMU, am I right?
Yes,
Atomic
sir.
mass units.
Yes, sir.
in kgs, this is 9 into 10 to the power of minus 31. This one usually we say if I ask the mass of electron.
Okay.
What Einstein found, this is actually called as rest mass, Nana. Means when the particle is at rest or moving with small velocities, like what we used to take in our first year, like 20 meter per second, 30 meter per second, like. But here the case is completely different. Here it is traveling when speed is comparable to the speed of light, then the mass changes. This is what he said. Okay, this is rest mass. If that rest mass is taken as some m naught and v is approximately equals to speed of light, the mass changes. What he said, mass of particle changes. Okay, according to the equation, Einstein equation, what he gave, anyone knows that equation, Nana?
No, sir.
Okay, he said m is equals to m naught by root of 1 minus v square by c square. This is a relativistic equation, what he said. Okay, means what he said, if the mass particle is capable to travel with a speed equal to the speed of light, if v is equals to c, he is saying that the mass of that particle tends to infinity. This is what he said. Okay, so it is practically not possible. That's why no particle in nature travels with a velocity equal to the speed of light. What he proved, Einstein proved. Einstein is not an ordinary scientist, so whatever he concluded, we have to accept. Okay, so this is the mass, Nana. So I have to replace the m here in all equations, not only there. For first equation, second equation, and in the third equation also, I have to change m as according to Einstein's equation, what I'm writing here. According to relativistic equation. There spelling correct, na?
RLA అనుకోండి సార్.
LA, relay. Oh, yeah, you are right. LA. There are Aryan?
Yes, sir.
LA, TI or TE, na?
TI only.
Yes సార్.
Okay. Relativistic equation. Right. M is equals to m naught by root of 1 minus v square by c square. The mass of electron changes. Okay, this is considered as fourth equation now. This one I am taking it as fourth equation. Take it as 4. So all together we have 4 equations here, Nana. Okay, by solving all the 4 equations, finally you will get the result. The result is, by solving 1, 2, 3 and 4, we will get finally the equation. In equation solve cheste final vache simple equation, lambda minus lambda dash equals to h by m naught c into 1 minus cos phi. ఇంత కష్టపడితే మనకు వచ్చిన చిన్న ఈక్వేషన్ ఇది. ఓకే, దిస్ ఈస్ కాల్డ్ as కాంప్టన్స్ ఈక్వేషన్. దీన్ని కాంప్టన్ ఈక్వేషన్ అంటాం మనం. Okay, so will you accept this equation? మీరైనా తిరిగి ఇంటి దగ్గర కూర్చొని సాల్వ్ చేస్తే ఇదే వస్తుంది నాన్న. ఓకే, 4 ఈక్వేషన్స్ కాబట్టి ఈవెన్ ఐఎమ్ ఆల్సో నాట్ ఇంట్రెస్టెడ్ టు సాల్వ్. Okay, it takes a
Okay,
lot
sir.
of time. I'm gonna like leave it. Finally, we will get this equation after solving the four. This
Okay,
is
sir.
Compton's equation, and here this lambda minus lambda dash is called as where? Lambda minus lambda dash is called Compton shift. Compton shift means shift in the wavelength. Okay, that is taken as delta lambda. Okay, and here what is the right hand side? Nothing to explain. He constant, m naught constant, c constant, and here cos phi already I said it is scattering angle. Okay, now you can say that the Compton shift depends on whom and independent on whom. చెప్పచ్చు కదా నాన్న?
Dependent on phi, sir.
Only phi. Am I right?
Yes, sir. Yes, sir.
Compton shift depends, confidently I can write, only on the scattering angle. And confidently I can say it is independent of who, master?
Recoil
In the
angle.
theory, oh, we assume recoil angle, not only that is theta, what you are saying. What about the velocity?
Independent
Velocity
of
of
velocity of electron.
Velocity of electron.
Velocity. Very good. Velocity of electron. Okay. And it gave the strong support to the relativistic equation given by Einstein.
Yes, sir.
Yes. Am I right? And this is Compton shift. I am calculating delta lambda. Delta lambda calculate చేసేప్పుడు lambda తో నీకేం పనిరా? Do you ask lambda here while calculating delta lambda?
no, sir.
No, sir.
What you ask, just you ask phi, ante, that's it. That's why I write it. And the incident wavelength, or better I write wavelength of incident ray. The wavelength of incident ray. So these are the things on which it is independent, and this is
Sir.
the only one thing it depends on.
ఇది లాంబ్డా డాష్ మైనస్
Yes.
లాంబ్డానా సార్?
Correct, brother. Sorry. Shirama. You are right. Lambda dash minus lambda. Why? Because already we assume now it is lambda dash.
Yes,
is greater
లాంబ్డా
than
డాష్
lambda.
గ్రేటర్.
Yeah. So this is the equation. What we do here. Okay, good. This is the story now. Right? And that too you can say this one in a short form also. Why? Because all the three things are constants. If you substitute the values of h value, m naught 9 into 10 to the power minus 31 speed of light, if you substitute, finally you will get lambda dash minus lambda, which is delta lambda, is equals to, that value is 0.0243 angstroms. That value means 0.0243 into 10 to the power minus 10 if you solve this part, into 1 minus cos phi. See here in numericals, in just one step we can solve this one. No need to calculate this part again in exam. Okay, directly you can remember like this. Is it clear, Nana?
Yes, sir.
Right.
Yes,
Good.
sir.
So when we come to exam, we never try to remember this formula. We try to remember this one. When we come to IP part, then we try to remember this equation. Okay. Then here at different angles, what will be this Compton shift? We try to calculate. Okay, like cases. Case 1. Suppose if I take that scattering angle is 0. Phi is 0 means what I'm trying to say, Nana? The striker is hitting any coin here?
No,
No,
sir.
sir.
Means there is no collision. If there is no collision, according to this quantum theory, this energy is not absorbed by anyone here, and you should get on the other side lambda dash equals to lambda if this theory is correct.
Correct on.
Correct, Nana?
Yes, sir.
Theoretical
Zero
lambda
వస్తుంది.
is equal to lambda dash. రావాలి, లేదంటే ఈ టోటల్ ఎక్స్ప్లెనేషన్ విల్ బి రాంగ్. ఇన్ని ఈక్వేషన్స్ తీసుకొని కష్టపడి సాల్వ్ చేసేదంతా రాంగ్ అవ్వాలి. సో litmus test here, one small litmus test. If phi is equals to 0 degrees, that is the incident ray is unscattered, means undeviated, then delta lambda is equals to exactly, I think you will get 0 only. Correct, Nana?
Yes, sir.
Why? Because this is cos 0 is 1, this whole thing becomes 0. Delta lambda is equals to 0. That implies exactly you are getting lambda dash equals to lambda or not?
You're getting, sir.
Means theoretical whatever we got the same here according to the equation. Okay, so we have to believe the derivation here. So whatever the Compton assumed, by assuming that as two-dimensional elastic collision is correct. Okay, so litmus test is over. Next, case 2. Suppose if that is scattered by an angle 90 degrees. After hitting, suppose it goes in this direction. Okay.
Then maximum delta lambda will be
Yeah. Same thing Papam Compton also assumed. He also thought that it is maximum. Case 2. Here I am taking. If phi is equals to 90 degrees, pi by 2. Okay, deviated exactly perpendicular to the incident, then delta lambda, I think I will get 0.0243 only angstroms. Correct, Nana? Cos 90 is 0.
yes, sir.
Then by that lambda dash is equals, of course I can calculate it. Taking the lambda to the other hand, lambda plus 0.0243, and he also thought that it is maximum, and in a hurry he named it as his wavelength, Compton wavelength.
సార్ 180 degrees అయితే అప్పుడు మాక్సిమం వచ్చిన
మాక్సిమం అప్పుడు అవుతుంది యాక్చువల్గా అయితే. ఈయన అదే మిస్టేక్ చేశాడు, ఎంత మెత్త మేధావి కాంప్టన్ కూడా. ఓకే, అంత తొందర ఎందుకు పేరు పెట్టుకోవడం, అప్పుడే కాస్త చెక్ చేసుకొని పేరు పెట్టుకోవచ్చు కదా.
But sir, 180 degrees,
Yeah.
it should return back, no, sir.
Yeah, it should scatter. Yeah, in the same path it should go back.
There will be lot of difference.
It is
no, sir.
possible. It is. That's what I'm saying.
Lot
That should
of
be the
energy-
maximum Comptonship now.
Yes.
If phi is equals to 180 degrees, means scattered exactly in opposite direction, then delta lambda, I think you will get 0.0243 into 2.
ఎస్ సార్
Cos 180
Yes, sir.
minus 1, 1 minus of minus 1 is 2 times. Then you are getting delta lambda is equal to 0.0486 angstroms. That implies lambda dash equals to, you are getting 0.0486 plus lambda. Actually, it is maximum wavelength. Okay, maximum wavelength of scattered ray. Means you have to understand that if phi is equals to 180, the energy scattered will be much less. That is the minimum energy scattered. Most of the energy will be given to the electron. Now you understood?
Yes, sir.
that implies E dash is minimum. Scattered energy is minimum. Why? Because it is maximum. Wavelength is maximum. So in that case, it scatters by losing most of the energy to electron. And why we should not say loss of energy? No. Why? Because it is elastic collision. There is no loss. That's why loss, whatever it lost, that should be given to the electron. Okay. In this case, we can say happily that implies energy supplied to the electron. Supplied to the electron is maximum, and that equals to, can I write E minus E dash nano? Is it correct?
Yes.
Right.
Correct.
In this case, energy supplied is max. Right. Good. These are the different cases, nano, and I take it as case 3. Okay. Same part again. If you go to your advanced exam, they ask here not only related to the Compton wavelength. If you come to mains and MSET, they ask only the Compton wavelength part, Nana. But if you come to advanced, they ask using the equations in the middle here. They ask what, find out the recoil angle, find out the speed, like. Okay. After finding out lambda dash here, you have to again solve these two equations, Nana. Understood my intention?
సార్ ఇక్కడ వాళ్ళు ఈ ఎమ్ ఇస్తారా లేదా ఆ ఎమ్ కూడా మనమే కనుక్కోవాలా?
M అంటే అది M నాట్ ఇంటూ ఇది ఉందిగా 1 మైనస్
అదే
V స్క్వేర్
సార్,
బై C స్క్వేర్.
అదే అది వాడాలా లేదా అది ఇస్తారు అంటున్నా?
కంపల్సరీ. అంటే వాడు ఇచ్చే స్పీడ్ని బట్టి నాన్న.
ఓకే.
ఇప్పుడు V ఈజ్ ఈక్వల్స్ టు సే సమ్ 2 ఇంటూ 10 పవర్ 5 అన్నాడు అనుకో, అవసరం లేదుగా.
ఎస్ సార్.
Why? Because it is suppose 3 into 10 power 5 అన్నా అంటే C by 1000 కదా అది.
అవును సార్.
అప్పుడు C స్క్వేర్ చేసినప్పుడు ఇంకా తగ్గుతుంది కదా వాల్యూ, అంటే V స్క్వేర్.
అవును సార్, అవును సార్.
1 by 10 power 6 అవుతుంది ఇక్కడ. హియర్ యూ విల్ గెట్ 1 by 10 power 6 అంటే సబ్స్టిట్యూట్ చేయాల్సిన అవసరం ఏంటి? అందుకని అది చూసుకొని, అదే 3 into 10 power 7 అని ఇస్తే వీ హ్యావ్ టు
ఇప్పుడు చేయాలి.
అది వైజ్లీ యూ హ్యావ్ టు డిసైడ్ ఇన్ ద ప్రాబ్లమ్ నాన్న. అప్పటికప్పుడు యూ హ్యావ్ టు టేక్ ద డెసిషన్ డిపెండింగ్ అపాన్ ద గివెన్ వాల్యూ ఆఫ్ వెలాసిటీ ఆఫ్ ఎలక్ట్రాన్. ఓకేనా? Based on this, will you solve one numerical?
Yes sir.
చేస్తారా నాన్న?
Okay.
ఇక్కడే అడుగుతున్నాను మీకు. In this case one example here, in this case one, in case one, suppose lambda dash is equals to lambda nana, exactly. అంటే it is not hitting. ఇక case one అవసరం ఏముంది నాన్న? I think directly I can say the velocity of electron equals to 0 and theta equals to 0. ఇవి క్యాలిక్యులేట్ చేయాలన్నా నాన్న?
No need, sir.
Is it required?
No need.
Here
No,
only you
sir.
will get straight away. MV, yeah, అది అవసరం లేదు. ఇక not required.
If it doesn't hit only,
velocity
sir,
of electron,
obviously 0.
it doesn't hit na.
Yeah,
Obviously velocity of electron is 0, so theta equals to 0. If you require some theory, here I write, since it does not hit the electron. Okay, it is clear. So here I can ask, okay, or in case 3 also I can ask. Okay, in case 2, suppose if I ask example, find the velocity of electron, velocity and recoil angle, of velocity and recoil angle, recoil angle of the electron here. Okay. You want required angle of electron when phi equals to 90 degrees and lambda equals to take it as 0.024, 2 decimals తీసుకున్నాను 0.024 and lambda equals to 0.026. Okay, take like this angstroms. Okay, in bracket delta lambda is equals to 0.024 angstroms when phi is equals to 90. Now you understood my data here, Nana, what I gave?
Yes, sir.
Right.
Yes, sir.
ఈ కేసులో you have to solve velocity and recoil angle. ఇప్పుడు you have to go to that equation. ఇంకా ఆ equations లోకి వెళ్ళాలి మనం.
సరే ఇప్పుడు
Okay.
ఫస్ట్
ఇంకా కావాలి
హెచ్ డాష్ అదే ఈ డాష్ తెలిస్తే అప్పుడు ఎనర్జీ ఈక్వేషన్ లో వేస్తే వి వస్తుంది.
అంటే ఈ రెండింటి నుంచి ఐ థింక్ యూ విల్ గెట్ వి బై స్క్వేరింగ్ అండ్ యాడింగ్.
అవును సార్.
Yes, sir.
Correct?
Yes, sir. Yes.
Yeah, by squaring and adding you will get v. So ఈ రెండు ఈక్వేషన్స్ ఇప్పుడు వాడాల్సి వస్తుంది.
First you will send
So
the
I am moving back.
h by lambda dash
Ah,
other side. You get
సార్
that
అన్నిసార్లు
is
స్క్వేర్
cos
చేసి
90
సార్
కదా నాన్న?
స్క్వేర్ చేసి ఆడే బదులు ఎనర్జీ ఈక్వేషన్ లో డైరెక్ట్ వేసేయచ్చు కదా సార్.
అప్పుడు ఏది
నెక్స్ట్ పేజ్
వాట్ ఎవర్ ద ఎనర్జీ
కైనెటిక్ ఎనర్జీ ఈక్వేషన్
అదే వస్తుంది ఇక్కడ కూడా. అంటే సరే ఓకే అలా అయినా చేయొచ్చు, ఇబ్బంది ఏం లేదు. వాట్ యు ఆర్ సెయింగ్ సార్, లాంబ్డా ఈజ్ నోన్, లాంబ్డా డాష్ వీఆర్ కమింగ్ టు నో, ఇట్ ఒబేస్ లా ఆఫ్ కన్సర్వేషన్ ఆఫ్ ఎనర్జీ కాబట్టి బెటర్ వి గో టు ద థర్డ్ ఈక్వేషన్ అంటాను, అంతే కదా?
అలానే సార్.
తీసుకోవచ్చు, తప్పేం లేదు.
అంటే ఒక స్టెప్ తగ్గిపోద్దని.
నో ప్రాబ్లం మీ మెథడ్కే వద్దాం. Solution here lambda is equals to 0.026 and lambda dash equals to, I think I'm getting by adding this one 0.05, correct Anana?
Yes sir.
0.024
correct,
plus 0.026 0.05. According to the LCLE, what you are saying, law of conservation of kinetic energy, okay, is hc by lambda. Angstroms lo undi kabatti can I use my shortcut nana? 12,400 by lambda gurtunda adi?
Yes sir, gurtu.
So 12,400 or 1240 na?
400 sir.
12,400.
400
nanometer
not 1,240. Yeah, good. So hc by lambda 0.026 plus kinetic energy of electron, half mv square, is equals to, here I have to take what, 12,400 by 0.025, 0.05. All are in electron volts now.
Sorry, kinetic energy right side lo kad sir.
Oh, ఇది రావాలి కదా. You are right. Right. Incident energy plus 0 equals to KE plus 12,400 by 0.05. You are right. Then we will get the answer. Okay, in the next page. That is by doing some calculation. Enta ostundara idi? 026 అంటే 1 2 3 ఇంకో 3 zeros పెట్టాలి. 12,400 లేదా కామన్ తీస్తే I think I will get 0.026 minus 1 by 0.050 equals to KE. ఇప్పుడే అబ్జర్వ్ చేయండి, ఏమైనా మిస్టేక్ ఉంటే ముందుకెళ్ళాక చెప్పకండి. 0.026 minus 0.05 కరెక్టే కదా నాన్న?
కరెక్టే సార్.
అప్పుడు 1 2 3 zeros ముందుకు తీసుకొచ్చేస్తాను. 12,000 అంటే 124 into 10 power 5, 1 by 26 minus 1 by 50. is equals to KE. This is in electron volts. సో జూల్స్ లో కన్వర్ట్ చేయాలంటే డివైడ్ చేయాలి. సో 124 into 10 to the power of 5 divided by 1.6. ఇది డివైడెడ్ చేస్తాం, మల్టిప్లై చేయాలి కదా. 1 electron volt is equals to 1.6 into 10 to the power of minus 19 కదా నాన్న.
Yes, sir.
Yes, sir.
Into
Yes, sir.
10 to the power of 19 into LCM straight away I take it at 26 into 50. This is 24. Okay, Nana?
Correct, sir.
This is the kinetic energy in joules. Straight up. This calculation could be cheyal Nana.
Yes, sir. Okay, sir. Okay, sir.
Okay. By this you will get the
Then
kinetic
half
energy.
MV
సార్
square.
ఈ బ్రాకెట్ లో రాసింది 0.0184.
ఏది నాన్న?
24/26. అవును సార్.
0.0184.
0.0184.
Yeah. మరి ఈ మల్టిప్లికేషన్
3.65, sir. Totally. Means into.
ఫైనల్ ఆన్సర్.
Yes, sir. 3.65 into 10 power minus 14, sir.
Even by
Yes, sir.
multiplying with
Yes,
0.0184.
sir.
Okay, final.
సేమ్
Final,
వచ్చింది
sir.
సార్. సేమ్ వచ్చింది సార్.
Right, okay. 3.64 into 10 to the power of 14 joules is equals to the kinetic energy. ఇక్కడ నుండి you have to calculate the velocity నాన్న.
Half MV square.
అది కూడాను క్యాలిక్యులేట్ చేస్తే కానీ మనకి తెలియదు వెదర్ ఇట్ ఈస్ కంపారబుల్ టు ద స్పీడ్ ఆఫ్ లైట్ ఆర్ నాట్. ఓకే, మళ్ళీ అది స్పీడ్ ఆఫ్ లైట్ వచ్చిందంటే దెన్ వీ హ్యావ్ టు కన్సిడర్ ఎం యాజ్ ఎం నాట్ బై 1 minus v square by c square. అందుకని ఫస్ట్ చెకింగ్ హియర్ కైనెటిక్ ఎనర్జీ ఒక 2 minutes లో కంప్లీట్ చేస్తాను అయిపోతుంది.
0.81.
నాన్న హౌ మచ్?
0.81 into the 10 power 9 means 10 power minus 23.
That might can. No, Nana. That is v square maybe.
Yes, sir. Means this is 0.81, sir. That multiplication and division. 9 by 2 if you take
all together. Right?
Yes, sir.
4.5, 3.65 divided by 4.5 is how much, Nana?
0.81.
This is 0.81.
Yes, sir.
Into 10 to the power of 31 minus 14?
17.
25, 17.
17.
Plus 17.
Yes.
After taking LCM, 0.081 and 0.9.
Yes, sir.
Sorry, after taking root.
0.9.
0.
Is not divisible.
Or 16 అంటే 8 మళ్ళీ √10. ఇది కంపారబుల్ టు ద స్పీడ్ ఆఫ్ లైట్ వెళ్తుందిరా
ఎస్ సార్.
కదా?
ఎస్ సార్.
ఇలా చేస్తే నీకు మోర్ దాన్ 3 వస్తుంది చూడు.
It is coming.
√10 value approximately 3.
28.46 coming, sir.
Into
10 power 8.
No.
Sir, 2.84 into 10 power 8, sir. 2.84 into 10 power 8.
So I did into 9.
Conclusion. Right. 2.84 into 10 power 8 అంటే కంపేర్ టు స్పీడ్ ఆఫ్ లైట్. సో చెకింగ్ అయిపోయింది. ఇప్పుడు ఇక చచ్చాం మళ్ళీ మనం. We have to move back to take the mass as m naught by
1 minus v square by c square.
Yes, root of 1 minus v square by c square into v square is equals to 3.65 into 10 to the power of minus 14. ఓకే, ఇక దీని బేస్డ్గా ఇప్పుడు మీరు సాల్వ్ చేయాలి అబ్బాయి.
ఈ మెథడ్ ఎందుకో నాకు రాంగ్ అనిపిస్తుంది సార్.
ఈ మెథడా? ఎందుకు
సార్ అంటే ఇప్పుడు ఇది v అనేది దాని ఒరిజినల్ వెలాసిటీ కదా సార్. అదే మనకు తెలియదు. ఇక్కడ మనం వచ్చే సబ్స్టిట్యూట్ చేస్తే తప్పు వెలాసిటీ ఉంటది.
ఎందుకు నాన్న?
Original 0 no sir. U 0.
అరే we applied using law of conservation of static only na.
అవును సార్.
This equation
అప్పుడు
we
యాక్చువల్ గా హాఫ్ ఎం రావాలి కదా సార్, మనం ఎం నాట్ సబ్స్టిట్యూట్ చేసాం కదా సార్.
అదే నాన్న నేను అంటుంది, నేను కంపేర్ చేశాను. అంటే హియర్ సపోజ్ v is much less than c అయితే డైరెక్ట్లీ we can take m as m naught కదా.
అవును సార్, కానీ అలా అవ్వలేదు కదా సార్, మనం ఎం నాట్ సబ్స్టిట్యూట్ చేసినప్పుడు సికి కంపారబుల్ గా వచ్చింది.
అందుకే దాన్ని ఎరేస్ చేసి మళ్ళీ మొదటికి వచ్చాం.
అదే సార్, ఇప్పుడు వి ప్లస్ లో మీరు అదే వాల్యూ వేస్తారా?
ఆ వాల్యూ అయ్యాను అసలు నన్ను, అది కరెక్ట్ రాంగ్ కదా వాల్యూ వి వాట్ వి క్యాలిక్యులేటెడ్ ప్రీవియస్లీ. ఇప్పుడు క్యాలిక్యులేట్ చేయాలి మళ్ళీ సెపరేట్ గా.
అర్థమైంది సార్ ఇప్పుడు.
ఓకేనా? రైట్, అంటే అది జస్ట్ చెకింగ్ వెదర్
కన్ఫ్యూజన్, చిన్న
అదే చెక్ చేసాము, కానీ మనకు అన్లక్కీలీ వి గాట్ అప్రాక్సిమేట్లీ సి వస్తుంది. సో ఆ మెథడ్ వైలేట్ అయిపోయింది మనకి. అది కాదు మెథడ్, దట్ ఈస్ నాట్ ద మెథడ్. అగైన్ వీఆర్ కమింగ్ బ్యాక్ టు బై టేకింగ్ ద రిలేటివిస్టిక్ థియరీ. ఓకేనా? దీని బేస్డ్గా టుమారో వి విల్ కంటిన్యూ ద క్వశ్చన్ నాను.
ఓకే.
టుమారో మీన్స్ ఆన్ మండే.
ఇంకా టైం ఉంది కదా సార్ కొంచెం.
ఇంకా చాలే అబ్బాయి, ఇదంతా చాలా క్యాలిక్యులేషన్. దీనికి వెళ్ళాలి, దాని నుంచి మళ్ళీ ఆ 2 ఈక్వేషన్స్ సాల్వ్ చేయాలి. ఇక స్టార్ట్ చేసామంటే అది 11:30 అవుతుంది. ఓకే, అందుకని ఇప్పుడే స్టాప్ చేయడం బెటర్.
ఓకే.
సో ఇఫ్ యూ వాంట్ యూ కెన్ టేక్ ద పేజెస్ now.
yes sir.
Right, first part, first page, second page, third page, and fourth page. మీకు ఏమైనా పాసిబుల్ ఉంటే ఇది కొద్దిగా సాల్వ్ చేయండి నాన్న.
ఓకే సార్.
సార్
ఓకే, దీని నుంచి కొద్దిగా సాల్వ్ చేసి వెలాసిటీ వచ్చేస్తే నెక్స్ట్ క్లాస్కి మనం డైరెక్ట్ కంటిన్యూ చేసుకోవచ్చు. ఓకేనా?
ఓకే.
రైట్, బాయ్ నాన్న ఎవ్రీవన్. స్టాప్ చేసేస్తున్నా క్లాస్.